Alright, so in this video, we're going to be talking about the cross product, okay? So this is the second type of vector multiplication, and, well, now some advantages of this is that your product is a vector, okay? So now we're going to be having not our product as a scalar, which was the dot product, okay? With that, we had a scalar product, but with the cross product, now we have a vector product, okay? So that's the reason why this cross product is also called the vector product. Okay, but anyways, your other advantage is that A cross B, that's how you say it, is going to be orthogonal to both A and B. Okay, so basically what you end up with is a normal vector. So say that you have both A and B, and this is a right angle. Well, now that vector right there is going to be A cross B. Okay, it's going to be a vector that is orthogonal to both of those vectors. Okay, now one quick note. Okay, before we even start here, how do I know whether A cross B is going up or it's going down? Because those directions are both orthogonal to A and B. Well, you have to use, you can use the right-hand rule, but honestly, I haven't really had the best of luck with that. Not sure why, but the way that I do it, that's the simplest for me, is I imagine a screwdriver, okay? If I put a screwdriver and I start at vector A, okay, because that's where I'm starting, A, and then I go to vector B, so A cross B, if I'm turning to B, then I'm turning left, right? I'm turning left. I'm turning counterclockwise. And that means that I'd be loosening a screw, okay? So that means that it's going to be coming out, right? So I'll be going up. So now to find the cross product, what we have to do is set up a 3x3 matrix. Okay, so we're going to review just real quick how to find the determinant of a 2x2 and a 3x3 matrix. So if you want to find the determinant of a 2x2 matrix, you may already remember this. Okay, this may be ingrained in your head. But the determinant of a 2x2 matrix is basically AD minus BC. Okay, so you multiply this diagonal and then you subtract this diagonal. Okay, simple as that. Now the determinant of a 3x3 matrix is a little more complex. Okay, so now what you have here, okay, is you have three pieces, okay, three terms. The first is going to be right here. That is A times this 2x2 matrix. Okay, and the determinant of that 2x2 matrix. Okay, you have to find the determinant of this. All right. Next, okay, next you have B, and then you have times the determinant of this 2x2 matrix. Okay, and I noted here, be careful because you have a negative there. Okay, it's minus that and not plus that. Okay, so that's going to be something that a lot of people mess up when doing cross product. So just keep that in mind for now. Now the last part here is this C portion here. Okay, and that's C times, you probably guessed it, this 2x2 matrix right here. Okay, so it's basically the 2x2 matrix that is not in the same column as the letter that you're dealing with. Okay, so for C, it's the 2x2 matrix for these two columns. Okay, and we're not counting the top row in that 2x2. All right, for A, it's going to be not in this column, it's going to be in these two columns right here, the E, F, H, I. All right, so that's kind of how we're getting this here. So here is basically how you find the cross product, okay? So like I said, we're finding the determinant of a 3x3 matrix, okay? And we set that up. We have vectors A and B. And if we're doing A cross B, we put our unit vectors on the top, I hat, J hat, and K hat, okay? And that's just going to give us each component of our new 3x3, or our new 3D vector, okay? And for our second line, that's going to be vector A, okay? And for our third line, that's going to be vector B, okay? So that's how you set up the 3x3 matrix. Now, this is going to be equal to, we do our first part, okay? Remember, that was this I hat, okay, times this 2x2 matrix right here, okay? And the determinant of that is just going to be, well, AD minus BC, which is A2 times B3, minus A3 times B2, right? Now, next we have minus J hat, okay? We have minus J hat. Here is that minus, okay? Remember, this is what I said to be careful of, so I'm going to circle that in red. Now, we have this J hat times A1 times B3 minus A3 times B1. Okay, so now you're setting up a 2x2 matrix excluding this center column here. Okay, now you have lastly plus K hat. Okay, so you're doing K hat this time. That means you're not talking about this column. You're talking about the 2x2 matrix right here. Okay, so to find the determinant of this 2x2 matrix, you have A1 times B2 minus A2 times B1. Okay, and that is how you find the cross product. So let's do a quick example. Let's do 1, 2, 3 cross 4, 5, 6. Okay, so we set up our 3x3 matrix. What goes on the top? I hat, J hat, K hat. What goes in the second row? Our first vector, which is 1, 2, 3. Now, in the third line, that's our second vector, 4, 5, 6. And now we find now we can find the determinant of this 3x3 matrix. So first up, we have I hat times the determinant of this 2x2 matrix right here, the 2, 3, 5, 6. Okay? And that's going to be 2 times 6, okay, 2 times 6, minus 3 times 5. Next, we're going to have minus J hat times, we have a 1 times 6, which is 6, minus a 4 times 3, which is 12. Then we have plus K hat. And then we're going to have the determinant of the 2x2 matrix, 1, 2, 4, 5. Okay? And that's going to be 1 times 5, which is 5, minus 4 times 2, which is 8. Okay? And now this is going to be equal to, you have I hat times, this is a 2 times 6, which is 12, minus 3 times 5, which is 15. That gives us negative 3, which gives us negative 3i. Next, we have minus J hat times 6 minus 12. So 6 minus 12 is going to be negative 6. We're going to multiply that by negative 1 here to get plus 6 J hat. Okay? And lastly, we have 5 minus 8, that's negative 3. So we get a negative 3 K hat. And if you put this is basically in our unit vector form, but what we can do is put this into angle bracket form. Okay, that's kind of what I've been choosing to call these different types of forms to write a vector. Anyways, if you want to put this in the angle bracket form, this becomes negative 3, 6, negative 3 in our angle brackets. Okay, so right there, that is your cross product. Alright, so we're going to be doing some more practice with this in the next video, so I'll see you then.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.